Here we have a motherboard that came in for repair. The motherboard looks something like this. And the customer mailed over the motherboard without the CPU and RAM sticks. Why? I do not know. It just makes it more difficult on us to be able to diagnose and test the board. Including the CPU and RAM sticks is not going to make the package bigger, it's not going to make it heavier, and it's not going to cost you more to ship that device. Why not include it along with the motherboard? The model number of the board is, customer wrote, MSI Z790I Edge Wi-Fi. And what's wrong with the board? Motherboard not working at all. When I turn on the power, no beeps, no lights, no fans, nothing. This happened after I tried to upgrade the CPU. So the CPU is the hint. Maybe we have a problem with the socket. Yeah, I do see problems with the socket. Looks like we have a lot of bent pins on the top, on the right, on the bottom, on the left, everywhere. Is it worth it working on this motherboard? How much is this board? Let me look it up online quick. And the board is going for $329. Now the thing is, the motherboard does not power on. No lights, no fans, nothing. I do not know if by fixing the pins, the CPU pins, if we're going to get this board to work or not. We cannot test the board if the pins are shorting out. So we're going to have to fix the pins and hope that bent pins or shorted pins are what's causing the board not to power on. We're going to have to waste time fixing a lot of pins. And that's something that we have to do in order to know if that board is going to work or not. The problem may not be the socket. The problem may be something else. But how can we test? If two pins are shorting out, the board may not turn on. Depends on what the pins do. And if we do a quick visual inspection, we see a bent pin right here that we should be able to fix, no problem. We have one right here. Not too bad. This socket design is one of the worst in history. We are in 2023 and this socket is still being made. You do not just have pins, but those pins are curved in a certain way. You cannot unbend the pin back like factory. We can make it not short out, not touch another pin, but that's about it. What about changing the whole socket? It's neither practical nor economical from a business point of view to change the socket. We have an issue here. You know what? We have a lot of bent pins. Why not just take it one step at a time? Let's start with the first column. Make sure everything's good. Sometimes you will lose focus if you keep staring at the pins. So why not do it column by column? That way we can see every pin and focus our eyesight on that one specific column. Along with this pointy tweezer. So the first three columns are good. I mean, imagine you have this and you're trying to figure out which one is bent. You can kind of tell by looking at the pattern if there's anything wrong, like here. You see the pattern broke right here, so we know we have a problem. But I'm going to take it one step at a time, one column at a time. We have a bent pin right here. And all it takes is just one tap. Look at this one. Look at this one. How are we going to unbend this pin? Now you see the pin broke from the top and we're only left with those two pins on the bottom. Just look at the design of the pins. They split from the bottom and then you have that curvy head from the top. Crazy. I do not know the job of this pin. It may be in no connect, or maybe it's redundant with other pins. But we're going to jump over to another section of the socket. That's all we can do. And how are we going to charge the customer for this repair? We're not. We're just going to charge a bench fee, diagnostic fee, or what's known as a repair attempt fee. It's a minimal fee to compensate for diagnosing the board. In this case, we're not only diagnosing the board, but I'm actually working on it. But we're not going to charge the customer for a repair. We cannot guarantee this repair, and we cannot even test the board. But I'm going to go over the pins, just do the best that I can, and we'll just charge a repair attempt fee. A customer mails over, let's say, a laptop. We open it, take out the motherboard, we work on it, diagnose the board, and we're not able to figure out the issue. We charge the customer for a bench fee, repair attempt fee, to compensate for some of the time spent working on that device, disassembling the device, looking at the board under the microscope, under a thermal camera, reassembling the board, packaging, shipping. All that stuff takes time. Otherwise, if we do not do this, then we're going to get a lot of junk in the shop here. A customer knows that his device is not fixable. He took it to 5 other shops, but he'll say to himself, let me send it over to NorthridgeFix. If they don't fix it, they're not going to charge me. And we're going to end up getting a lot of junk. So when somebody knows that they're going to have to pay a bench fee or a repair attempt fee, they're going to think twice before mailing their junk here. And that's what we want. I think we are all set. We did the best that we could. Hopefully it works out for the customer. But if it doesn't, the customer will have to spend around $300 to get another board, which is not a big deal. Just be extra careful when upgrading your CPU in the future. That's all I can tell the customer. Now, if we look next to the power socket, do we see anything obvious here? Maybe a blown component or a knocked off component on the edge. Any components on the edges? We have a lot of components on the edges, right? But we do not have anything missing, anything ripped. And look here, and look at this. Look at this. It looks like we have a damaged capacitor here. As long as that capacitor is not shorting to ground, we should be good. What happened here? Meter in diode mode. Look at this. Is that a short circuit? Let me go to ohms mode. And in ohms mode, I'm reading 0.3 ohms. Is that normal? And on the other side, I'm reading 0.2 ohms. I think the cap is shorted to ground. That's what I think. It's a bypass capacitor. A shorted bypass capacitor can cause issues, but if we remove the capacitor completely, it's not going to cause any issues, and it's not going to prevent the system from working. It's only a filtering cap, so it's better not to have it than have it. Okay. And then we're going to measure again to see if we still have a short. Maybe that was the problem to begin with. Maybe that's why the motherboard is not powering on. Let's measure again. Look at this. I'm reading 0.37 voltage drop. So that cap was shorted to ground. That capacitor was shorted to ground. We have ground here, and we have 0.37 voltage drop. Before, we were reading a short on both pads. Again, we found that component because of visual inspection. I always look at the edges of every board I work on because I see it a lot where a component is knocked off or a component is damaged from the very edge of the board. We're not going to test the board. We do not even know if the socket is working to begin with. We have a broken pin, and a lot of the pins, we straightened them, but they are not 100% factory. I did remove a short circuit by removing the shorted cap, if that would help or not. But like I said, we're not going to charge the customer for a repair. We're going to charge the customer for a bench fee, and we charge for a bench fee for every device that comes in the shop here. I just took some of my time to straighten the pins and do what I could, but we're not going to charge the customer for the repair. That's it. We're going to end the video right here. I hope you enjoyed it. Don't forget to like and subscribe, and we'll do something else in the next video.